Okay, let's talk about some applications of diodes now. The first application we'll look at is for voltage protection. We also call this a voltage clamp. So we are actually going to have some time varying input voltages now, which you can see over here on the left. So this is something we'll work with a lot more later in term. But let's start here at 0 volts. So at 0 volts, none of the diodes are on, nothing's happening, the output's 0 volts. What about there around maybe 0.5 volts? Let's see what's happening then. If this is 0.5 volts, then that is not enough voltage to turn on both of these diodes in series. This one's facing the wrong direction, so none of them are on. So if none of them are on, there's nowhere in this picture right now for current to flow. So therefore, there's no voltage drop across this resistor, and therefore the voltage over here at this node is also 0.5 volts. We're considering this ground. So that means that in that case, V out is just equal to what V in is, the 0.5 volts. Okay, so now let's go look at different case. Okay, what if we get those two diodes in series turned on? So let's say we have 2 volts now. We're up here and we're at 2 volts. So if this is 2 volts, that's more than the forward voltage of each of these combined, because 0.7 plus 0.7 is 1.4. So these LEDs are on, current can flow like this. And because they're both on, they're actually fixing the voltage now at this top node up here to 1.4 volts, the combination of their forward voltage. So that means that anytime now the voltage is going above that 1.4 volts, these diodes turn on and clamp the voltage up here at 1.4 volts. So let's draw the output now. So we said the output was just following the input until we hit 1.4 volts, and then it just went flat. And so then as the voltage starts coming down on the sinusoid, again, once it gets below 1.4 volts, start tracing downwards here. Oh, start tracing downwards. Okay, what happens when we go negative? So we expect, well, let's erase our pictures there. Okay. We expect this diode to turn on once the voltage is at least negative 0.7 volts. And so what happens before that when we're at negative 0.5 volts? We have negative 0.5 volts here. Again, there's nowhere for current to flow. These are off. This is off. So there's no voltage drop here. So this is negative 0.5 over here. So the same thing as we're tracking. And then when we get above 0.7 volts, then this diode should turn on. And once that diode turns on, it's going to clamp this voltage here to be plus minus 0.7. So that means it's going to be sitting at negative 0.7 volts. So let's actually make our picture a little more proportional over here. Okay. So now we're only going to come to 0.7 down here. So it's just going to track the input and then be flat and then track the sinusoid. So you can imagine we have a sinusoid like this, only we're clamping that voltage at a maximum and a minimum in this circuit. Okay, the second application we're going to look at is a rectifier. So this takes a voltage that is both positive and negative over time at the input and takes the absolute value of it and makes an only positive output. So a good use for this circuit might be if you have AC power coming into your house and you want to supply a positive DC power instead to some circuit device. So this looks pretty complicated, but we're just going to break it down into pieces step by step. So first we're going to look at the case where over here where the input voltage is positive. So in the case that the input voltage is positive, current is flowing this way. This diode's off because it's facing the wrong direction, but current can flow this way and then flows through that load resistor there and then over this way and back around. And this diode is, again, facing the wrong direction for current here, so it's off. Now, when we have a negative voltage input, we're going to turn on different diodes. So now the current's flowing this way. It's going to flow through this diode, and this time this diode's facing the wrong direction and is off. Current will then flow this way through RL, and then this way through the diode, and again, current's the wrong direction here, so this one's off, and then back around. So what's interesting about the circuit is it turned on different diodes each time, but current flowed right to left through that resistor in both cases. So that means that we actually got a positive voltage out each time in this circuit. So even though we input down here below, we can see we input a positive and then a negative voltage. We got out positive voltage and then positive voltage. So that is called a rectifier. And that is just two examples of circuits you can build with diodes.